Hello everyone. Today I am going to present about multiprocessor benchmark. First, let us understand what a multiprocessor system is. A multiprocessor system contains two or more processors that work together to execute a task at the same time. Instead of a single CPU handling all operations, the workload is divided among multiple processors. This allows tasks to be completed faster and improve overall system performance. However, simply adding more processor does not automatically guarantee better performance. There are many factors such as communication between processor, memory sharing and task synchronization that affect the final result. Because of this, we need a way to measure how efficiently multiprocessors are working together. That is where multiprocessor benchmark comes in. Multiprocessor benchmark is a test used to measure the performance of a system that has multiple processors executing tasks simultaneously. It evaluates how well the processors cooperate and how much improvement we get compared to a single processor system. Now the question is, why do we need multiprocessor benchmark? We use them to compare multi-core system, evaluate parallel processing performance, measure scalability, and check how efficiently the operating system schedules tasks. In addition, benchmarks help researchers and engineers identify bottlenecks and improve system design. Let me explain with a simple example. Suppose one processor completes a task in 10 seconds. Ideally, we use two processors. The task should complete in 5 seconds, but in reality, it may take 6 seconds instead of 5. This difference happens due to communication delay between processors, synchronization overheat when processors coordinate with each other, and shared memory access conflicts. These overheads reduce the expected performance gain. There are two important metrics used in multiple benchmarks. The first one is speed up. Speed up indicates how much faster the system becomes when multiple processors are used. Speed up is calculated by dividing execution time with one processor by execution time with multiple processors. The second metric is efficiency. Efficiency tells us how effectively the processes are being utilized. Efficiency is calculated by dividing speed up by the number of processors. If efficiency is high, it means the processors are being used effectively. If efficiency is low, it means some processing power is being wasted. Let us look at an example. If a task takes 20 seconds on one processor and 8 seconds on 4 processor, the speed up is 20 divided by 8, which is 2.5. Ideally, 4 processors should give a speed up of 4, but we only get 2.5 due to overhead. The efficiency becomes 2.5 divided by 4, which is 62.5%. This means the processors are not fully utilized. Multiprocessor benchmarks are commonly used for tasks like matrix multiplication, sorting large data, scientific simulation, and database operation. These tasks can be divided into smaller parts and executed in parallel, making them suitable for multiprocessor system. Another important point is that benchmarking is not a one-time task. It is an iterative cycle of measurement, analysis, and refinement. First, we measure the performance, then we analyze the result to identify bottleneck. After that, we improve the system or algorithm. Finally, we benchmark again to see whether the performance has improved. This cycle continues until optimal performance is achieved. Multiprocessor benchmarking also help in evaluating scalability. Scalability means how well the system performs when the number of processors increases. A good multiprocessor system should show improved performance as more processors are added. To conclude, multiprocessor benchmark help us understand how effectively multiple processors work together, measure performance improvement, identify bottlenecks, and improve system efficiency. They play an important role in designing high performance computing systems. Thank you.